So we have discussed physical properties of acids and bases and also the difference between acids and alkali. So today we have discussed the chemical property of acids and alkalis, or you can say bases. Okay. So before going to discuss the chemical properties, I told you in the last class regarding indicator. Okay. If you want to know the presence of acid and base, if you want to know the presence of acids and base, so you are supposed to have an indicator. So, indicators are going to show different colors in different environments. Different color environments. Like I mean to say that let's suppose, let's suppose we have a list of indicators. Okay. I think in the last class we discussed regarding universal indicator. How can we check the strength of acid by using universal indicator? Universal indicator show different colors. Universal indicators show different colors in different pH. Like sometime it shows blue color, sometime it shows orange color, sometime it shows dark green color, sometime it shows light green color, sometime it's quite red color. So, it would be showing the pH of different solutions. So, this is the table in which you can see the first indicator is we have that is blue litmus paper. Color in acid solution, it would be red. Color in alkaline solution, it would be blue. And methyl orange, it's pink in acid, it's yellow in alkaline condition. Okay. And methyl red, it's red in acid, it's red in acid, and yellow in alkaline condition. Phenolphthalein, then you have phenolphthalein. So phenolphthalein is colorless in acid but pink in alkaline condition. Okay. Then red litmus, it's red in acid and blue in alkaline condition. You have to memorize this. You have to memorize this. Remember. Okay. So because examiner would be asking, this indicator is dash in acidic solution and this indicator is dash in basic solution. So at that time, if you know the color, you will write the color. If you don't know the color, so you would not be able to write down that is specific color. Are you getting my point? Okay.
Yes,
Yes or
sir.
no? Yeah. Okay. So number one thing is that we have different chemical properties of acids and bases, different chemical properties of acids and bases, including like the very first reaction of acid is that acid reacts with metals. Okay. Acid reacts with metals. Let's suppose, uh, let's say, let's say this one. Okay. Reaction of acid with metal. Reaction of acid with metal. So first of all, you need to know when acid would be reacting with metal, it would be forming salt and hydrogen gas. It would be forming salt and hydrogen gas. That's fixed. That's 100% fixed. salt and hydrogen gas. Okay. So let's say I have HCl, which is going to react with sodium. Let's suppose I have uh, hydrochloric acid and it's going to react with metal. So it would be forming salt and hydrogen gas. So what would be the salt? Of course, sodium chloride and hydrogen gas and hydrogen gas. Okay. So let's suppose I have zinc. It can also react with HCl. It would be forming salt, that is zinc chloride and hydrogen gas and hydrogen gas. Okay. And also you can see that uh, magnesium can react with HCl. It can produce magnesium chloride and hydrogen gas. Okay. So let's say we have calcium. It would also react with HCl. Since it's in group 2, it would be forming the same salt, that would be calcium chloride and hydrogen gas. It's quite simple. It's quite simple. And also I have iron. It would react with HCl. It would produce iron chloride, FeCl2 plus hydrogen gas. And then we have aluminum. It would react with HCl. It would produce AlCl3 and hydrogen gas. Okay, it would produce AlCl3 and hydrogen gas. Okay, so what would you observe? That's the main thing. What would you observe? So remember, due to the formation of hydrogen gas, due to the formation of hydrogen gas, we would observe effervescence. We would observe bubbles. Bubbles, effervescence, the same thing. Okay. So you have to mention observation. You have to mention observation. Observation. Observation means we would see effervescence. Effervescence or bubbles. Effervescence or bubbles. Okay. So let's suppose in this reaction, I have hydrogen gas, hydrogen gas, hydrogen gas, hydrogen gas, hydrogen gas. This is your first observation. And then if it would be of 2 marks, so then you are supposed to write solid disappear. Solid disappear. Like, of course, you know that it's solid, zinc is solid, magnesium is solid, calcium is solid, iron is solid, aluminium is solid. So when it would be reacting with hydrochloric acid, they would be forming salt, 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 and the salts are aqueous. And the salts are aqueous, like they are soluble in water, like they are soluble in water. So of course, you will see that you had solid initially, and when the reaction is going to proceed, so the solid is going to disappear. Why? Because it would be reacting with that acid, with that acid. Okay, so these are observations that you are supposed to write when the examiner would be asking. Are you getting my point? Okay.
Yes, sir.
Yeah. And also uh, then we might have other acid. we might have we might have other acid. Remember, like we might have sulfuric acid. We might have sulfuric acid. Like I'm going to take the same metals. I'm going to take the same metals. I'm going to take the same metals like they are. Okay, so this one, and so, but now it is going to react with H2SO4, 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 and then H2SO4. So they would be producing again the same thing, salt and hydrogen gas. Okay, they would produce salt and hydrogen gas. That's it. So in the case of sodium, it would be forming sodium sulfate. It would be forming zinc sulfate. It would be forming magnesium sulfate. It would be forming calcium sulfate. It would be forming iron sulfate. It would be forming aluminium sulfate. And of course, the hydrogen gas would release. And of course, hydrogen gas would release just like that. And again, you will have the same observation, and again, you will have the same observation, like effervescence, like bubbles, okay, due to the formation of hydrogen gas again, due to the formation of hydrogen gas again, okay. And if examiner would be asking to write down the word equation, sometime he asks to write word equation. So whenever your acid is hydrogen chloride, hydrochloric acid, so the salt would be sodium chloride, zinc chloride, magnesium chloride, calcium chloride, iron chloride, aluminium chloride, like chloride, chloride, metal chloride, metal chloride, metal chloride. And whenever your acid is sulfuric acid like H2SO4, like sulfate, so the salt would be sodium sulfate, zinc sulfate, magnesium sulfate, calcium sulfate, iron sulfate, aluminium sulfate. So the salt would be sulfate. Okay, and sometime examiner would be, you can say, examiner would be asking to write down equation with nitric acid, of course, with nitric acid. Okay, nitric acid is HNO3. Nitric acid is HNO3. So you would be forming the same thing. Nitric acid is HNO3, so you would be forming the same thing. Let's suppose, let's suppose this is the one. And right now I am going to have HNO3. I'm going to change this. Right now we have HNO3. HNO3, like nitric acid, nitric acid, nitric acid. Okay, this is nitric acid. And then again I have nitric acid, that is HNO3. So you know what would be the salt? Nitrate. What would be the salt? Nitrate. Nitrate. So the formula of the salt would be, you can see that it would form NaNO3, zinc nitrate. Since the charge of zinc is 2, so I would write 2. Magnesium nitrate, again the charge of magnesium is 2. Calcium nitrate, again the charge of calcium is 2. Iron nitrate, again the charge is 2. I need to write 2. Aluminium, the charge is 3, so I need to write 3 over there. This is the formula for the salt. This is the formula for the salt. Okay. So again, same observation. Again, you would have the same observation. You would have the same observation. Okay. So sometime you will see the acid would be organic acid. Sometimes you would see the acid would be organic acid. That is ethanoic acid. That is what? Ethanoic acid. Or sometime you would see propanoic acid. I would be telling you the formula, don't worry about that. Or sometime methanoic acid, butanoic acid. So should be over there. You know what's the formula for methanoic acid? HCOOH. Ethanoic acid CH3COOH. Chiku, chiku, chiku. Propanoic acid CH3CH2COOH. Butanoic acid CH3CH2CH2COOH. This is butanoic acid. Okay. So now they all are going to react with now they all are going to react with the metal, that is sodium. This is weak acid. This is what? This is weak acid. So weak acids can only react with the reactive metal, would not be reacting with the least reactive metal, since already they are unreactive, since already they are weak. So they require some strong conditions. Right? Now, as a result, what would be the product? As a result, what would be the product? Of course, acids are proton donors. They give hydrogen. Okay, just like that. HCOONA and hydrogen gas, and it would be forming CH3COONA and hydrogen gas. It would be forming CH3 CH2 CHCOONA plus hydrogen gas. It would be forming CH3 CH2 CH2 COONA plus hydrogen. So the summary is that whenever the acid is going to react with, like, this is your organic acid, which is methanoic acid, ethanoic acid, propanoic acid, or butanoic acid, is going to react with the sodium, that is more reactive metal, it's in group 2. So it would be forming this salt and then hydrogen gas. Okay, is that okay?
Yes, sir.
Yes, sir.
Yes, but keep in mind that some metals some metals would not react some metals would not react with acid, like, or I can say there would be a very, 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 very slow reaction, like copper. like copper so copper is not going to react with any of the acid. Remember, okay, copper is not going to react with any of the acid because copper is the least reactive metal. Are you getting my point?
Yes, sir.
Yes. So, and also when acid reacts with metal, just like that, just like that, just like that, just like that. So when acid reacts with metal, it's a redox reaction. It's very important point. I'm going to connect this chapter with the redox. I'm repeating, when acid reacts with metal, it's a redox reaction. But how? But how? What's the charge for sodium over there? You will say 0. What's the charge for sodium? Of course, this is +1. When sodium is present in any of the compound, it would be always +1. So the charge is going from 0 to +1. Of course, the charge is changing. Of course, the charge is changing. So this is redox reaction. Of course, the charge is changing. So this is redox reaction. But, but, but when acid reacts with an alkali, so it's not a redox reaction. I would be explaining you later on when we would be discussing the acid base reaction. But right now I'm discussing the reaction of acid with metal. The reaction of acid with metal. So what I told you, some metals that are least reactive are not going to react with uh, like the metals, like the least reactive metal. Okay, should I go ahead?
Yes, sir.
Yes,
Okay,
sir.
good. And you can say that. Okay, so then I need to write down an ionic equation. I need to write down an ionic equation for the reaction of metal with acid. Ionic equation. Ionic equation. So in ionic equations, we do cancel spectator ions. We do cancel spectator ions. So let me tell you how can we write down an ionic equation. Let's suppose this is an equation, sodium solid, which is going to react with HCl. It's aqueous, and it's going to form sodium chloride aqueous and hydrogen gas. Listen very carefully. So the rule says you are supposed to, the rule says you are supposed to write down, you are supposed to break down those compounds which are aqueous, which are aqueous like that. Sodium, then H plus Cl minus aqueous, then sodium chloride, sodium aqueous, Cl minus aqueous, and hydrogen gas, Okay. Only you are supposed to break down aqueous one. Only. So after this, you are supposed to cancel. You are supposed to like cancel Cl minus and then Cl minus because they are the same. Because they are the same. And after doing this, the remaining one would be your final answer. The remaining one would be your final answer. So Na reacts with H plus, it's going to form Na plus and hydrogen
Exactly.
gas. So then we are supposed to balance this equation. I would be writing this thing. This is an ionic equation for the reaction of acid with metal. Metal is sodium and the acid is sodium. Acid is HCl. What if I'm going to give you this one? What if I'm going to give you this one? So what would be an answer? Yes?
Sir, I'm doing.
Sir, do we cancel SO4?
Yep.
Yeah. Mg plus H2 gives us Mg plus H2.
Mg
Plus H2
Mg plus H2 and then
gives us Mg plus H2.
this one.
Yeah.
Okay. Are you saying the same thing, Mariam, or different one?
Sir, I don't know for this one.
Okay, see this. First of all, you have to break it down into this one. This is magnesium solid. Sulfuric acid gives us 2H positive ion and sulfate like that. I'm going to write down state symbols. And since this is also an aqueous, so I'm supposed to break it down in this one, this manner. And hydrogen gas would remain the same. And hydrogen gas would remain the same. Then I'm going to cancel it out. So the remaining one would be the final answer. That would be this. That's it.
Yes, sir.
Or you can do this. Yes.
Sir, is it 3Al plus 2H plus Al3 plus H2?
2Al
3Al plus 2H plus Al3 plus H2.
like this. Al solid. HNO3 would be converting into this one, aqueous aqueous. Then aluminium nitrate is this one.
Yes.
Hydrogen gas. Cancel. I would be writing this thing. I'm supposed to balance this.
Yes, sir.
Okay. Yeah. Okay. So this is an ionic equation that you must know for each and every metal. For each and every metal. Okay. Then reaction of acid with base, or you can say alkali.